Hey class, so before we start talking about power, I'm gonna do the quick review over work. The first part is true false. So number one says a watt is a standard metric unit of work. That is actually going to be false. Why? Because it says watt, and that is not the unit for power. The power for work is joules. Number two, an object moving to the right, a force acts leftward upon it, the force is doing negative work. That is going to be true. It's causing the object to slow down, and it's going in the opposite direction of the object. 3. Work is a time-based quantity. It depends upon how fast a force displaces an object. That is going to be false. Work has nothing to do with how fast you do it. It only depends on the force and the distance involved. 4. You apply a force to a wall, but it does not move. This is an example of work. That is false. The reason that's false is because it says it does not move. So there's no distance to be calculated, and anything times 0 is going to be 0. So no work is being done. 5. A book falls off the table and free falls to the ground. This is an example of work. That is going to be true. So the book is falling, so there is distance to calculate. And the reason this book is falling is because of gravity. And we all know that gravity is a force, so we can use that force times the distance to calculate that work being done. The next section is multiple choice. 1,200 kilogram car and a 2,400 kilogram car are lifted to the same height at a constant speed in a service station. Lifting the more massive car requires blank amount of work. So the more massive car is this 2,400 kilogram car, and it is double the mass. So if it's double the mass, that means it's going to be twice as much force, which means it takes twice as much work to lift. 7. A child lifts a box up from the floor. The child then carries the box with constant speed to the other side. During the scenario, when was the child doing work? So that is going to be just A. When he lifted the box. So when he lifted the box, he applied the force up and the box moved up. Carrying an object requires you to go horizontally, and carrying the object also requires you to continue that force going up. And you see that those are not in the same direction, so no work is being done. Because that's that 90-degree angle, cosine 90 will give you 0. Anything times 0 will be 0 work. So A is your answer for that one. 8. Which requires more work? Lifting a 50 kilogram cart or crate a vertical distance of 2 meters, or lifting a 25 kilogram crate a vertical distance of 4 meters? That is going to be C. It requires the same amount of work, because when looking at this, it has double the mass of the crate, but this crate, the crate that has half the amount of mass, did double the distance. So if you doubled the mass but half the distance, it would equal the same amount of work. And then finally, we're going to be looking at the math problems. 120 kilogram woman is doing squats as a form of exercise. While applying a force to the center of her mass, she travels 68 centimeters. If her goal was to perform 40,000 joules of work, how many squats would she need to accomplish? So first we need to find work. Work again is force times that distance. They do not give us the force. Again, they give us the mass. And that force is going to be found by mass times gravity. So the mass is 120. Gravity is 9.8. You're going to multiply those two together to get 1,176. And that is your force. So 1,176 multiplied by your distance. That is in centimeters. We need to convert it to meters. So 68 divided by 100 will give us 0.68. Plug that into the distance. Multiply those together to get 799.68. So that is the amount of work for one of these squats. And we want to know how many squats would she need to accomplish if she did 40,000 joules. So divide those, and you're going to get about 50 squats as your answer. Number 10. A 43 Newton object or force acts on a block at an angle of 32 degrees of the horizontal. The block moves a distance of 6.7 meters. How much work is done by the applied force? So for this one, work is going to be force times distance times the cosine of the angle they give us. So our work here is going to be measured in newtons, which is 43. Our distance they give us is 6.7 meters. And our cosine, 32. And again, when you're solving these equations, make sure that your calculator is in degree mode, not radian, because we are doing the trig and that needs to be in degree mode. So multiply all those together to get 244.3 joules. And that is how much work. Number 11. Looking at the picture to the right, how much work is the dad doing pulling his daughter on the wagon? So we see that the force they give us is 50 newtons. The distance is 30 meters. And the angle of the horizontal is 30 degrees. So our work is going to be our force times our distance times the cosine. We're going to multiply all those together to get 1,299 joules. And that is the work review.